Physics Part 203. Going round in circles. At the end of this section, you should be able to describe qualitatively motion in a curved path due to a perpendicular force and understand the centripetal acceleration in the case of uniform motion in a circle. You should be able to express angular displacement in radians. You should be able to understand and use the concept of angular velocity to solve problems. You should be able to recall the use V is equal to RW to solve problems. You should be able to recall and use centripetal acceleration. A is equal to RW square, A is equal to V square over R. You should be able to recall and use centripetal force F is equal to mRW square and F is equal to mv square over R. Centripetal force. Newton's first law of motion tells us that an object with a resultant force of 0 acting on it will either not be moving at all or will be moving in a straight line at a constant speed that its velocity does not change. The object is said to be in an equilibrium. The full condition of an equilibrium requires there to be no resultant force or resultant moment acting on the body. An object traveling in a circle may have a constant speed, but it is not traveling in a straight line. Therefore, its velocity is changing. Since velocity is speed in a certain direction, a change in velocity means the object is accelerating. In the previous chapter, we dealt with the objects moving along a straight line, where acceleration related to changes of the speed. In circular motion, objects accelerate because their direction changes. The acceleration of A of an object moving in a circle of radius r with speed v is given by the expression A is equal to v square over r. We shall derive this later. This acceleration is towards the center of the circle. It is called centripetal acceleration. In order to make an object accelerate, there must be a resultant force acting on it. This force is called centripetal force. From Newton's second law of motion, the force F to give mass m and an acceleration is F is equal to ma. By substituting for A, the centripetal force is F is equal to mv square over r. The centripetal force acts towards the center of the circle. This means that the centripetal force acts at the right angles to the instantaneous velocity of the object. Consider a ball on a string which is being swung in a horizontal circle. The tension in the string provides centripetal force. At any instant, the direction of the ball is velocity is along the tangent to the circle as shown in the figure. If the string breaks or is released, there is no longer any centripetal force. The ball will travel in the direction of the tangent to the circle at the moment of the release. We've got an example for you. An aircraft in a display team makes a turn in a horizontal circle of radius 500 meter. It is traveling at a speed of 100 meter per second. A. Calculate the centripetal acceleration of the aircraft. B. The mass of the pilot in the aircraft is 80 kilogram. Calculate the centripetal force acting on the pilot. A from A is equal to V square over R, the centripetal acceleration is A is equal to 100 square divided by 500, which is equal to 20 meter per second.